Okay, we're going to look at what is known as the 7-step graphing approach. There are often different ways to approach graphing a function, but your textbook is pretty specific about asking you to follow a set list of guidelines. So we're going to go through all 7 of those steps as it would apply to the MML, doing this sample problem, f of x equals 3x over x minus 2, and we're going to go through each step and see how that works. The first step we need to look at is symmetry. Does it exist, and what kind exists if it does? And we do that by looking at f of x and comparing it to f of negative x. So we're going to look at f of negative x, and everywhere we see an x, we're going to put in a negative x. And simplify that solution by multiplying the 3x times the negative x and getting negative 3x. There's not a whole lot of simplification we can do on the bottom, so we're just going to leave it alone. And we are actually going to say that there is no symmetry as far as the y-axis or the origin because our f of negative x is not equal to our original. So we're going to say there's no symmetry with regards to the y-axis or origin, because f of x is not equal to f of negative x. Secondly, we're going to move on from there and look at a y-intercept. And a y-intercept is where the graph would cross the y-axis. And to do this, it seems a little bit counterintuitive, but we actually fill 0 in for x. And that's because x is 0, and we're looking for where it crosses the y-axis. So I'm going to plug 0 in everywhere I see an x, and get 0 over negative 2, which would be 0, which would mean the y-intercept is actually 0, which means it actually crosses at the origin. So the y-intercept is 0, which means it's going to cross at the origin, or 0, 0. Our third step is going to be to find the x-intercept, which is a similar idea to the y-intercept, except it is where it crosses the x-axis, not the y-axis. And we do this by setting the entire function equal to 0 and then solving for x. And we're gonna get rid of this fraction because we don't like to deal with fractions by cross multiplying. And it is kind of convenient that 0 times the bottom, because 0 times anything is 0, and then we're just left with the top. And we're going to divide by 3 to get that 3 out of there and get x is equal to 0. So it does cross at 0, 0, which is actually what we found in part 2. This is just a way to show that that's also the x-intercept as well as the y-intercept. When we move on to part 4, and I'm going to try and fit them all on here, we're looking for the presence of vertical asymptote. And vertical asymptotes are found by setting the denominator equal to 0. So I'm going to just remind you of that. Set denominator equal to 0, and our denominator is x minus 2. We're going to set that equal to 0 and solve, and get a vertical asymptote of x equals 2, which means if you can imagine a graph, right, x equals 2 might be somewhere about here. There's an imaginary vertical line that the graph will not cross at x equals 2. It will approach it, but it will never cross that kind of boundary point. Okay, part 5 is to look for the presence of horizontal asymptotes, and we can do that by looking at our leading coefficients. And our leading coefficients, we look at those because each our denominator and the numerator have the same degree, which means there's no squared in one of them, or there's no cubed or any other exponents. They both have exponents of 1. And so we look at the leading coefficient, or the first number. And remember that I know you don't see a number in front of the x, but it really is there. It is a little imaginary 1. So our horizontal asymptote would be 3. And again, if you look at our graph, that would be kind of a little horizontal boundary that the line would not cross. For part 6, we're going to choose a couple of what we call test points, or points to try out. And I'm going to put that over here so it does all fit on the screen. And we're going to evaluate the function at those. And I chose -6, 1, and 4. And it is a good idea to choose something on either side of the horizontal asymptote, so that's why I chose the 1 and the 4. And it's a good idea to choose a negative as well. Right? So this is going to be my x value, and I'm going to evaluate and find out what f of x is. And I'm going to do that by putting in, and I'm going to try and write small, my x value I chose for x. And I do want to remind you, please be careful of your signs. And the MML does require you to have a simplified fraction. So remember, a negative divided by a negative is a positive. We might also have to simplify that fraction by putting it in simplest terms, which in this case would be 9/4. I'm going to go ahead and do the 1, which is 3/-1, or -3, and the 4, which is 12/2, or 6. And those are some points that you could graph. -6, 9/4. 9/4 would be what? A little over 2. And these would be points that if you were to draw the actual graph, would be on that graph. 4, 6 would be somewhere there. So if you were to complete the graph, you would see those. Now, step 7 is not actually something I have to write down. It is to look at the graph. They give you 4 options, and you choose which graph fits the situation based on all this information that you have. So you want to look at things like asymptotes and make sure they're in the right spaces. And remember, you can zoom in on the graphs. I know they're hard to see because they're very small. There's a little magnifying glass next to each graph that will allow you to zoom in and see if it meets your criteria or not, and choose the one that best fits this situation. I hope you found that helpful, and you know where to find me if you have any questions.